All right. Happy Memorial Day, everybody. Just taking a look. If anybody comes on, we got our new microphone. We got one like out there already. Just gonna do a little review. We got two people. Happy Memorial Day, everybody. Just looking over tomorrow's math lesson. So, wanted to do a little front loading, as they would say, before the lesson. But hope everyone is enjoying this lovely rainy weather. So if you're in here, just let me know who's in. Curious to see who's joined. We got a couple likes. I'm actually just let me see if I can move it. Just going through some old video game systems. Hooked up my Wii. Giving this a try. Circa 2010. I won't go through a tour. And we have some old school Super Mario, Super Nintendo. So, I'll lower this and we'll start. Look, wrong controller. All right, so we're gonna go over. We worked on volume. We worked on volume before about a couple weeks ago, before we took those tests. So we all know that volume is length times width times height. It's pretty much it when you have three-dimensional shapes. So any kind of object, like right here, we have an Avengers 48-piece puzzle that Eddie was working on. If we wanted to find the volume of this shape, you'd have to find the length, the width, and the height of it. And once you get all three of those dimensions, you would just multiply them together to find the volume. But what we're going to be working on is, I guess you'd say we'll be working on non-traditional shapes, because the lesson is going to be finding the volume of composed figures. So it's pretty much going to be, what if we have two shapes and we put them together? How can we find the volume? So that's what we're going to be doing tomorrow. We're going to be working with certain shapes that we may have to break them apart and find the volume of two shapes separately, and then add up the volumes and put them together. But we'll work on that tomorrow. Just wanted to review. No one's in here. We got one person in here. I thought I would have some interaction, some comments, but I know it's Memorial Day, and I'm just playing around still with the YouTube Live. So I do have a new microphone, so I don't know if we could tell the difference, thanks to Will, or Juice Gaming Edits. Give him a shout out. So let me look at Let me look at some vocabulary. Well, we went over in class, yes, we went over polyhedrons and non-polyhedrons. So we know that a polyhedron is a 3D shape that has flat surfaces or flat faces. Non-polyhedrons have non-flat or curved surfaces. So, for example, a cylinder would be a non-polyhedron. We looked at a cone. Cones would be non-polyhedrons, and polyhedrons would be rectangular prisms, rectangular pyramids, um, square pyramids, triangular prisms. Any shape that has any three-dimensional figure that has flat faces is a polyhedron. Um, Also, prisms, we went over. Prisms are three-dimensional shapes, and they have two bases. Okay, so here we have. This wouldn't be the best example, but we know that prisms have the faces of a prism are all rectangular, and the bases, they have two bases, which which each have the shape of a polygon. So if we have a triangular prism, you're going to have the two bases that are triangles that have the shape of a triangle, and each of the faces will be a rectangular. Then we have pyramids. Pyramids have one base, and that base is the shape of any polygon, and all the faces will be triangular. So you could have a square pyramid, and you'll have a base that will be a square, which is where the name comes from, and you'll have the faces, which will all be triangular. And a triangular pyramid, or all pyramids, come to a point up on top, which would be a vertex, or we more specifically would be an apex. And we did look, there is some, I guess you would say, depending on who you talk to mathematically or what book you look at, some people say that pyramids don't have any vertexes or vertices, it's just an apex. And some people say that it does have one vertex. But that's nothing that we need to go over now. But we just know that, going back to some key vocabulary, volume is the amount of space that's inside of a solid figure. So you can't find the volume of a two-dimensional figure because a two-dimensional figure is flat. So you can't find the amount of space inside of a flat figure. But here we have a three-dimensional. Here's the Avengers puzzle, the rectangular prism. And you can go inside and find the volume by measuring the length, the width, and then the height will give you the amount of space on the inside, which is your volume. The actual this face here is a rectangle. Your faces are rectangles, not sides. So we don't want to say that a rectangular prism has 6 sides, because I know that gave us some confusion, that we have 1, 2, 3, 4, 5, 6, or top and bottom, front and back, side and side, 6. Right? It's not 6 sides, because a 6-sided figure is a hexagon. But a three-dimensional shape that has 6 faces here could be a rectangular prism. So you just have to be careful when you're speaking about sides and faces. I'm trying to think tomorrow we have worked. I'm trying to look at some of the lessons that we've done for volume already in this unit. Well, we just covered the lesson on three-dimensional shapes. Well, then we know when we've worked with our unit cubes, which are the little base 10 blocks, the individual small cube. Before 5th grade, finding the volume, you would just count the cubes. You can count the amount of squares when they would give you a picture. I don't know if you'll be able to see it here, but when you would get a shape like that, to find the volume, you would just count 1, 2, 3, 4, 5, 6, 7, and you'd have your volume would be 7 unit cubes. That's the most basic type of volume problem that you'll have. We then moved on from the basic volume problem, where you, like I said, you could just count the cubes and find the volume, to where they give you a three-dimensional shape, and they give you the length, the width, and the height. And as long as you know Larry with Harry, length times width times height, you multiply them together, you'll find the volume. So tomorrow in class we're going to work on, let me see. Will be lesson 11.11, finding volume of composed figures. Okay, so those will be shapes where you're going to see it will be difficult just to find one length, one width, and one height. And you'll see tomorrow when we're working on it. So I will wrap this up right now, but I am curious to see anyone that is actually going to watch this from the beginning to the end. I know it's not the best live stream, especially that I'm starting to play with this towards the end of the school year. During the beginning of next school year, I hope to do unit reviews, how I would do my show me's. I'd like to throw in some live streams like this that I could review and take any questions that you may have, and really see which thank you. I have the math guy. I have Mr. Rudolph watching right now. Thank you. See? He's not a former student of mine. He's a former classmate. So I'm just, I got my new YouTube microphone. Okay. So anyone that does watch this, let me see. I had a question that I'd like. Here we go. I want to know if we have a polyhedron with one base that has 5 triangular lateral faces that meet at a common vertex. What is that shape called? So it's a polyhedron with one base that has 5 triangular lateral faces that meet at a common vertex. I want to see who could tell me what shape that is. And I'll be very impressed if someone comes in tomorrow and lets me know. So I think that will be it. As now I am actually trying one of my short-term goals. Long goals will be to the new Super Mario. Well, new as in 2010. I want to try to finally beat this game. That I have it set up on a small TV as I'm watching the Yankee game. So, on that note, I am going to X out and hope everyone enjoys the rest of their Memorial Day. So, we'll We'll see if this video gets any likes, subscriptions, comments. I'd appreciate it. All right, see everyone tomorrow.